Morning to all of you. So from today onwards we are going to another new chapter, triangle and its properties. Triangle and its properties. Now it is the introduction to that chapter. So in the previous classes all of you learned that some basic concepts about these polygons, which are closed curves, open curves, polygons made by line segments, mainly three line segments. Minimum three line segments are required to make a polygon, which is nothing but a triangle. That is the smallest polygon which can be made by the line segment. By using two line segments you cannot make any polygon which is a closed one. With the two line segment you cannot form any closed curve. Okay, minimum three line segments are required to make a polygon, that is nothing but a triangle. So today we are going to learn about the some basic properties of the triangle and its properties. So if you see the definition of a polygon here, a polygon is a simple closed curve made up of line segments. Mainly polygon is made up of line segments, that you have to remember. You know what is the line segment, which has a finite length and which has a starting point and an ending point. By using those line segments you can form any polygon, maybe a triangle which is having three line segments, or a quadrilateral which have four line segments, or pentagon which has five line segments, hexagon which has six line segments, heptagon which has seven line segments, octagon with 8 line segments, nonagon with 9 line segments, and decagon with 10 line segments. All these things you learned in the 5th class itself. Okay, now a polygon is made up of three line segments is called a triangle. Now your chapter belongs to particularly for triangles and its properties. A polygon made up of three line segments is called a triangle. A triangle has three vertices, three sides, and three angles. Three vertices, three sides, and three angles. Okay, these are the main elements of a triangle. Three vertices, three sides, and three angles will be there in any triangle. These are the main components of a triangle. If you observe the adjacent figure here, so this is a triangle which is made up of three line segments AB, BC, and AC. Okay, and three vertices, vertex A, vertex B, and vertex C. Okay, and another one is called three angles, angle A, angle B, and angle C. Angle A, angle B, and angle C. These are the main components of a triangle. And also a triangle can divide a given plane. So if you take this screen as a plane, this plane can be divided by a triangle into three regions. What are those regions here? If you observe here, the shaded part which is light bluish is called as the interior part of the interior region of the triangle, and the points which are existing in the interior are called as the interior points. Here D, E, F are called as the interior points, and exterior region of the triangle, which is outside the triangle. The points which are existing in the outside are called as the exterior points. I, G, H, J are called as the exterior points which are existing in the exterior of the triangle, and the points which are on the triangle are called as the What is that name here? You see, the points which are lie on the sides of the triangle are said to be boundary region. Okay, this is the boundary region. Here AB, BC and AC, only 2 points are here shown, which is L and K. So these two are the points on the boundary region. Points on the boundary region. So now if we take once again about the triangle, a polygon made up of 3 line segments is called a triangle. A triangle has 3 vertices, 3 sides and 3 angles. Okay, these are the elements of a triangle. And also a triangle can divide the given plane into 3 regions. So this is white color, this is the plane. This plane is divided by a triangle with 3 regions, which is interior region of the triangle, exterior region of the triangle and boundary region of the triangle. Okay, the points which are lying in the interior are called as the interior points. Okay, the points which are lying on the boundary are called as the boundary points. The points which are lying in the exterior of the triangle are called exterior points. Okay, so now we are going to another concept, classification of triangles. So triangles are mainly divided into 6 types, the two depending upon the sides and angles. So based on the sides, 3 types of triangles are there, and based on the angles, another 3 types of triangles are there. So triangles based on sides are scalene triangle, isosceles triangle, equilateral triangle. Triangles based on angles are acute angled triangle, obtuse angled triangle, right angled triangle. So these are the main types of the triangles based on the sides and based on the angles. Based on the sides are 3 types: scalene, isosceles, equilateral. Based on the angles are acute angle triangle, obtuse angle triangle, right angle triangle. Now let me briefly explain all the types of triangles separately. Now it is the scalene triangle. Triangles based on sides. This is the first one, is the scalene triangle. Scalene triangle means a triangle in which all the sides and all the angles are unequal is called scalene triangle. If you take any side, all are different with each other. All the sides are different with each other. All the angles are different with each other. So this type of triangles are called scalene triangle. If you observe, this is AB is 10.3 centimeters and BC is 12.65 centimeters and AC is 8.6. Means all the measurements of the sides are different here. So now it is a scalene triangle. If we take the angles, here it is 83.5, this is 43, 42.1, this is 53.97. So all the angles also different to each other. So this type of triangle is called a scalene triangle. Next one, this is isosceles triangle. Isosceles triangle means, you know, that a triangle in which 2 sides are equal is called isosceles triangle. 2 sides are equal, the third side is different. If we take the measurements of all the 3 sides, 2 sides will be exactly equal and the third side will be different. Okay, so this is the isosceles triangle. So if you observe here, this is 8.49, this is also 8.49, this is 12. This is different with these two. Okay, this type of triangle is called as isosceles triangle. And the property of isosceles triangle is, here it is, the angles opposite to equal sides are also equal in the isosceles triangle. If you observe, not only sides here, the angles opposite to equal sides. So if you take the equal angle, opposite angle to this side is, this is 45 degrees, opposite angle to this side is also 45 degrees. Here these 2 sides are equal. If you take the angles opposite to these equal sides, these angles also equal. Okay, that is the main important property of the isosceles triangle. What is that? The angles opposite to equal sides, the angles opposite to these equal sides are also equal. It's a here in this figure, this is 45 degrees, this is also 45 degrees. Okay, this is the isosceles triangle. An isosceles triangle may be a right angle triangle also. Maybe if one of the angle is 90 degrees and these sides also may be equal, then it is called as right angle isosceles triangle. Right angle isosceles triangle. Next we are going to the another type. This is equilateral triangle. The name itself tells that equi means equal, lateral means sides. The triangle in which all the sides are equal is called equilateral triangle. Equilateral triangle. A triangle in which all the sides are equal is called the equilateral triangle. And also in equilateral triangle, all the angles also equal. All the angles also equal. If we apply the property which is given in the isosceles triangle, the angles opposite to the equal sides are also equal, because in this equilateral triangle all the sides are equal, means the angles opposite to all the equal sides are also equal. Same property that can be applied here also. Here this side is 8.6, this side is also 8.6, this side is also 8.06. The angles, so the angles opposite to these equal sides are also equal. All these angles, the angle opposite to this side is 60 degrees. Here also the angle opposite to this side is also 60 degrees. The angle opposite to this side is also 60 degrees. Okay, so now an equilateral triangle is an equiangular with each angle measuring 60 degrees. In any equilateral triangle, the measurement of each angle is 60 degrees. The measurement of each angle is 60 degrees. By adding all these 60 degrees, 60 plus 60, 120, 120 plus 60, 180 degrees. In any triangle, the sum of the angles is 180 degrees. So 60 plus 60 plus 60 is 180 degrees. Okay, now we are going to learn about the triangles based on the angles. So now it is the triangle based on angle, which is acute angled triangle. Acute angled triangle. Normally all the triangles are acute angled triangles only, maximum. So a triangle in which each angle is acute angle, then acute angle means what? The angle which is less than 90 degrees. The angle which is less than 90 degrees is called acute angle triangle. So these are all the acute angles only here. Okay, so now if you take the font size bigger here, you can observe. See here, this is acute angle which is 57.43 degrees. Here also this is 53.13, this is 69.44. All the angles are less than 90 degrees only. All the angles are less than 90 degrees only. That's why these three angles are less than 90 degrees. Therefore this triangle is an acute angle triangle. We take one more example. So if you observe, this is 65 degrees nearly, this is 54, this is 60. This is also an acute angle triangle. If you take this is 67, this is 71, this is 40. All the angles are less than 90 degrees only. This is also an acute angle triangle. So in any triangle, all the angles are, if all the angles are less than 90 degrees, that type of triangle is called an acute angle triangle. An acute angle triangle. Okay, so now we are going to learn about the another type of triangle. Now this is triangle based on angles, which is second one, obtuse angle triangle. Obtuse angle triangle, OBTUSE, obtuse angle triangle. You know what is the definition of obtuse angle? Obtuse angle means which are less than, which are greater than 90 degrees and less than 180 degrees. All those angles are called as the obtuse angle triangle. The angle which is less than 180 and greater than 90 degrees, all the angles are called as the obtuse angle triangle. So a triangle in which only one angle is obtuse. See, in the acute angle triangle, all the angles are acute only, but in obtuse angle triangle, only one angle should be obtuse. If all the angles are obtuse, it will not form a triangle. Okay, only one angle may be obtuse angle. Remaining two angles are definitely will be acute angle only. Remaining two angles definitely will be acute angles only if one of the angle is obtuse angle. So then this type of triangles are called as the obtuse angle triangle. So if you observe, this is 119.47, which is greater than 90 and less than 180. So this is obtuse angle. So remaining two angles, this is 25 degrees, this is nearly 35 degrees. These two are acute angles only. Okay, in any obtuse angle triangle, only one angle will be obtuse angle, remaining two angles will be acute angles. If I change this, then also this is 138 degrees, which is more than 90. This is 20 and this is 20 again. These two again acute angles only. Okay, if I take like this is 124 degrees, which is more than 90 and less than 180. This is 19 degrees only. So this is also an obtuse angle triangle. This is also an obtuse angle triangle. Here 34, this is 32, these two are acute, and one of the angle which is 113, which is more than 90 and less than 180. So this is also an obtuse angle triangle. Okay, so this is the definition of obtuse angle triangle. Next one, this is the right angle triangle, particularly right angle triangle. Right angle means what? Which is equal to 90 degrees. If one of the angle of a triangle is right angle or 90 degrees, then that triangle is called as right angled triangle. Right angled triangle. Here observe here, this angle is exactly 90 degrees, one of the angle is 90 degrees, remaining angles must be equal to acute angle only. Okay, remaining angles will be acute angle only in any right angle triangle. Only one of the angle will be 90 degrees. So the side opposite to this right angle, is known as hypotenuse. The name for this side is called as the hypotenuse. That's why Hypotenuse, this one, hypotenuse. Okay, this side is called as the hypotenuse. The side which is opposite to the right angle is called as the hypotenuse. Why it is opposite, I will show you here. So now if it is right angle triangle, this is showing opposite exactly. This arrow is showing the opposite side of this right angle. So this is the opposite side of the right angle. So now this side is called as the hypotenuse, this side. Okay, so because it is opposite to the right angle. So now the side which is adjacent to this these two the sides which are adjacent to this right angle are called as the legs. Okay, remaining these two legs are called as the legs. These two sides are called as the legs. Okay, remaining these two sides are called as the legs. The side which is opposite to the right angle, this side is called as the hypotenuse. Okay, next we are going to next medians of a triangle. Medians of a triangle. So this is very important concept. In your next higher classes also you will get this concept. So because of that you have to learn this clearly. So now medians of a triangle means, first you have to know about what is median. A median of a triangle is a line segment. It is a line segment joining a vertex to the midpoint of the side opposite to that vertex. So how many vertices are there in any triangle? 3 vertices are there. If we take one of the vertex like this, some A here, so what will be the opposite side of this vertex? This is the opposite side of this vertex. So if we take exactly a midpoint of these two points B and C of this line segment, this side, and if you join this midpoint of the opposite side of this vertex with the A, then this line is called as the median of a triangle. This line is called as the median of a triangle. So like that, in any triangle, since three vertices are existing, you can draw three medians in any triangle. So this is one of the median which is drawn from vertex A to the opposite side of the vertex, and this is the median which is drawn from the vertex C to the opposite side of the vertex C here, and this is the another third median which is BE, which is drawn from the vertex B to the midpoint of the opposite side AC. Okay, this is the midpoint E. So like that, in any triangle you can draw three medians. In any triangle you can draw three medians. Okay, so now we will learn some extra properties for this. A median always lies in the interior of the triangle only. This median line always exists in the interior of the triangle only. This will not go to the outside. So see, observe here, all the three medians are lying in the interior of the triangle only. Even though we change the shape of the triangle, all the medians are lying in the interior of the triangle only. They are not going to outside anywhere. If you observe here, see here, just they are moving along with the triangle only. Okay, all the medians lie always in the interior of a triangle like this. And one more thing, a triangle has three medians which always meet inside the triangle. Here if you observe, these are the three medians which always meet inside a triangle at a particular point. The point of intersection of these three medians, this one, this red color's point, is called as the centroid of the triangle. Centroid of the triangle, the point of intersection of all the medians, the point of intersection of all the three medians is called as the centroid of the triangle. So this is the centroid, this one. Okay, centroid of the median. One more thing you have to remember in this medians concept, any median is divided by the centroid into 1:2 ratio. Okay, 1:2 ratio it will divide. Okay, if you observe here, so now if I take the rounding values, so now it is 3 centimeters, this is 6 centimeters, this is also 3 centimeters, this is 6 centimeters, this is also will be, this is 3 and this will be 6 centimeters. If we take the ratio of the measurements of these two values, which is 3:6, gives 1:2. 3:6 gives 1:2. So 1:2 means, from that you can understand that in any triangle the centroid will divide the median into 1:2 ratio. 3:6 means here to cancel this with the 3 table, 3 ones, 3 twos. So 1:2. Here also this is 1:2, this is also 1:2, this is also 3:6 only. So now the centroid will divide any median into 1:2 ratio. Okay, 1:2 ratio it will divide. That is the main important point. And always centroid is indicated by a letter Z here, which is nothing but a center of gravity of the triangle. This is nothing but a center of gravity of the triangle. So this is indicated by letter G here, centroid. Okay, this is the information about all the medians and what is the intersecting point of the medians and how the intersecting point divides the medians into 1:2 ratio. We will explain up to now. Now we are going to the another concept, altitudes of a triangle. Up to now we learned the medians of a triangle. Now these are the altitudes of a triangle. Altitudes means heights of a triangle. Heights. You know what is the height of a triangle? to find out the area of a triangle, we will take the height of a triangle which is drawn perpendicular from the vertex to the opposite side. So you drawn a perpendicular from a vertex to the opposite side. Okay. So if you observe here, altitude is nothing but the altitude of triangle is the perpendicular drawn from a vertex to the line containing the opposite side. Okay. If we take a vertex A here, what will be the opposite side of a vertex A here? This BC. For this BC, from the vertex A, if you draw a line which is exactly perpendicular, means which makes 90 degrees to this base, the angle should be 90 degrees in between this altitude and the baseline. Okay, then only this line is called as the altitude. Then only this line is called as the altitude or height of the triangle. If it goes from the midpoint of the opposite side, that is called as the median, which is explained in the previous one. Altitude may or may not go through the midpoint also. Altitude may go or may not go also. If it is an equilateral triangle, it may go through the midpoint of the triangle also, like this. Observe here, this is going to the midpoint of the triangle because it is nearly equal to equilateral triangle. So an altitude may or may not go through the midpoint of the triangle. If you observe here, these are all the altitudes. Here this is making, always it should make 90 degrees. That's why the altitude may move from midpoint to the other side, or left side to the triangle, or right side to the triangle also, like this. Okay. So that's why altitude may or may not go to the midpoint of the triangle, and always it makes 90 degrees to the opposite side. Like that, in any triangle you can draw 3 altitudes like medians. Here also you can draw 3 altitudes. From this vertices, if you draw a altitude, this will be the altitude here. From this vertices, this is the altitude. Like medians, altitudes also intersect at a common point like this. So this point is called as orthocenter. So the midpoint intersecting point of the 3 altitudes of a triangle is called orthocenter. The intersecting point of 3 altitudes is called orthocenter. And this orthocenter always will not exist in the interior of the triangle, and also the altitudes also will not always exist in the interior of the triangle like medians. They may exist in the interior, they may exist on the border of the triangle, and they may exist in the exterior of the triangle also. You know what is the interior, border and exterior. Okay, interior, border and exterior. So now the altitudes are existing in the interior and the orthocenter also existing in the interior only. If we take another type of triangle, then you can observe that what is the position of the altitudes and the orthocenter. So now it is exactly like some equilateral triangle. That's why all the altitudes are going through the midpoint of the opposite side, and also they are making 90 degrees. Now these 3 altitudes are lying in the interior only, and orthocenter also lying in the interior only. If I move this like this, now the altitudes are moving to the left side and the orthocenter is also moving to the left side. If I move further here and making it as a right angle triangle, all the altitudes are meeting at the vertex of the right angle triangle. Observe here, this is the orthocenter, and 3 of the out of 3 altitudes, 2 of the altitudes are coinciding with the remaining 2 legs, and only one is in the outer side. Okay, these 2 altitudes are coinciding with the legs, and this is the different altitude. Okay, so now If I move further to the left side, now all the altitudes here, this altitude is going to the outside, it is not existing in the inside of the triangle, and this altitude also going to the outside of the triangle, and this is also meeting at the outside of the triangle only. Now ortho center is existing in the outside of the triangle. Now the ortho center is existing at the outside of the triangle. Okay, so but in the median it will not exist like that. The ortho center only will move like this. Okay, so if it is a right angle triangle, ortho center will exist at the exactly at 90 degrees at the vertex where the 90 degrees is there here, and if we move like this, ortho center exists in the interior of the triangle. To the right side also same concept. Okay, if I move like this, right side also it will show the same concept like this. This is now it is existing in the outside, now it is coinciding with the legs, now it is in the interior of the triangle. Okay, so this is the main concepts you have to learn in the ortho center. Now we are going to the next one. Now this is the next concept, which is angle sum property of a triangle. Angle sum property of a triangle. Put a heading in your notes, angle sum property of a triangle. So what is the angle sum property of a triangle? The property is the sum of all the interior angles of a triangle is, the sum of all the interior angles of a triangle is 180 degrees. Here you know what is the interior, what is the exterior, and what is the boundary. So now this is the interior. The angles which are existing in the interior of all the angles are called as the interior angles. What is the property here now? The sum of all the interior angles is always 180 degrees. Always 180 degrees. Observe here, this is angle A is here 86 degrees, this is 53 degrees, this is 41 degrees. Now what you are getting here? 180 degrees. Now if you change the another shape of triangle, angles also will change. This is now 94 plus 55 plus 31. Again this 180 is not changing, it is constant here. Even though if you change all the angles and all the sides, it does not depend upon the whatever the angle it is there. It is always 180 degrees only. The sum of all the angles is always 180 degrees. Even though if it is a right angle triangle, one may be a 90 degrees remaining. If you add all these things, you will get 180 degrees only. Again, in any right angle triangle also, the sum of all the interior angles is 180 degrees. One may be 90 degrees. Remaining are the acute angles only. By adding these three, you will get again 180 degrees in this also. Okay, in any acute angle triangle also, 37 plus 83 plus 61, this is also 180 degrees. In a right angle also, this is 180 degrees. In an obtuse angle triangle also, see here, one of the angle is greater than 90 degrees, which is obtuse angle. Remaining are acute. In an obtuse angle triangle also, the sum of all the angles is always 180 degrees. Okay, so here if you observe here 169, remaining very short angles, 5 plus 5, 170 plus 5 plus 5 is 180. This is an obtuse angle triangle. Okay, if you move further here and if you coincide with this, now you are getting a straight angle which is exactly 180 degrees. Now it is a straight line, it is not forming any triangle, it is a straight line. Okay, if three points are in the same line, those points are called as the collinear points. We will get this concept in the higher classes. If three points are on the same line, they are called as the collinear points, and they will not form any triangle. Okay, if 3 points are not collinear or existing at 3 different places, they will form a triangle. Here, observe here, it is forming a triangle, obtuse angle triangle. The sum of all the angles is now 180 degrees. So like this, in any shape, the sum of all the angles is always 180 degrees. Okay, so this is the angle sum property of a triangle. If any two of the angles are given out of these three angles, any two are given, we can find out the third angle, because The sum of the angles is, you know, that 180 degrees. By subtracting the sum of remaining two angles from the 180 degrees, you can get the third angle. You can get the third angle. So this property is used to find out the angles, remaining angles or unknown angles of a triangle if two of the angles are given. Okay. So this is the very important property, which is triangle angle sum property of a triangle. Next one is exterior angle property, that you will learn in the next session. So now we are going to learn about the problems in exercise 10a. So but up to now I am going to conclude this session. In the next session I will explain the problems in exercise 10a. Okay, good day to all of you. Thank you.